So as I said, today I'm going to talk to you about the Node.js community's benchmarking efforts. To start out with, a little bit about myself. I'm Michael Dawson, a senior software developer with IBM. I lead the team within IBM that builds Node.js for bundling into our own products, as well as used by our customers through our products, cloud products like Bluemix. We've done a lot of interesting things like port V8 to PowerPC and the S390 architectures, and contributing the work needed to make sure that that Node.js can also run on those platforms, as well as participating a lot in the open source community itself. One of the things I'm personally involved in, and some of the other people from my team, is working in the benchmarking workgroup. Now, I'm just the one who has the pleasure to come here and talk to you about what we're doing. I just want to make sure that you know there's a lot of other people who are also involved in the workgroup and who are contributing to this ongoing effort. What I'm going to talk to you today is just really to start out with a little bit of an introduction to benchmarking, some of the challenges so that we have a level set. I'll then talk about the Node benchmarking workgroup, what specifically we're working on and what we've accomplished so far. And then finally, I'm going to loop back to a real-world example where one of the benchmarking workgroup team members investigated an issue and show you how some of the tools that I'll introduce in the first part were applied to debug that particular issue. The first thing that's really important to realize is that performance testing is not the same as functional testing. You know, with functional testing, it's relatively straightforward to write a test that's going to give you the same answer every time, and it either passes or it doesn't. In terms of performance, there's a lot of challenges that make it a lot harder. The first thing is that there's pretty much a guaranteed fundamental run-to-run variance. So every time you run your performance benchmark, you're going to get a slightly different answer, and that can really easily lead to false positives where you think, I've got a problem, but it turns out that no, that's not the case. So you actually have to run a whole bunch of times and often average those results together to be able to say, yes or no, I've actually got a regression or I've got an improvement. And so it's very important to document, you know, what is the expected variance so that when you get a result, you know whether you've got a problem or not. The second thing is that, you know, unlike functional testing, again, the environment, the tests are very, very sensitive to changes in the environment. You know, for example, if you run a benchmark on one machine with 2 CPUs and you rerun it on a machine with 4 CPUs, you're quite likely going to get a totally different result. So you have to make sure that your environment is very consistent. Even to the point where, you know, if you have a machine that's connected to a network, even if your benchmark doesn't use the network, just having a heavily loaded network might affect the overall results. So you have to be really, really careful about keeping that environment consistent. And that leads, you know, making sure that you know the machine state when you start your run, making sure the machines are isolated, not sharing networks. And often a technique used to address that is to actually have interleave runs where, you know, if you're going to compare 2 different versions, you'll do a run on one, then a run on the other, a run on the other, and back and forth. And that lets you make sure that you minimize changes that might be happening outside of your application runs as much as possible. And, you know, the key challenge I find is avoid jumping to conclusions. I think about 95% of the time when our performance team starts out and says, well, we might have a problem on this particular release of Node, after further analysis, it turns out, no, there wasn't any problem. It was one of the other issues that was going on. The other thing is that when you're making changes, you're really going to do yourself a big favor if you limit entropy. Try and limit the things that you change down to 1 dimension at a time. So only change your application code. Or if it's got NPM modules depending on, only change one of those. Don't change the Node.js version at the same time, or the machine. Try and make sure that you change one thing at a time. That's going to make it a lot easier to figure out what's going on. Overall, there's roughly 2 big categories that benchmarking will fall into. There's micro benchmarks and whole system benchmarks. Micro benchmarks benchmark a very specific thing. So for example, buffer.new. If you're concerned about how fast you can do that, you can easily write a benchmark that just does that a lot of times, and you can end up telling whether that's changed. The problem is that micro benchmarks often don't translate into real-world performance. So you can optimize for a bunch of micro benchmarks, and you may get really good performance on those benchmarks, but it may turn out that for real-life applications, that's actually the wrong thing to do. So whole system benchmarks try and say, let's take a benchmark which simulates real life. So Acme Air is one that's out there for Node.js, and it tries to simulate an airline reservation system. And the idea is that you end up with something that's going to give you a benchmark that shows you more what you're going to get in terms of real world performance as opposed to one specific thing. So you're looking at you know, some performance on Node.js, and you think you found a regression. What do? Well, the first thing is make sure. As I said, 95% of the time, in our case, it turns out to be that there really isn't a problem there, so make sure you revalidate that. Make sure your environment didn't change and you're not within your expected variation. If you convince yourself now, yeah, okay, there is a problem. So what happened? You have to start looking at what changed. So was it your application? Did you change the runtime or your overall environment? So assuming you've now narrowed it down to the runtime Node.js, you have to start looking at, let's compare between the good and bad cases. There's a bunch of tools we can use to try and give us hints as to where to look, and we could also just fall back to a binary search where we slowly narrow the scope of the changes that went in between the good and bad case. In terms of where to look, obviously, we can look at Node.js itself. Things like the buffer, cluster modules, depending on what you see as a regression, it might point you in one of those directions. But the first thing I'd personally look for, were there any major changes in the dependencies? So things like V8, OpenSSL, libuv, they can often have a significant impact on your performance. So I'd first rule out whether any of those dependencies have changed before I went on to anything else. In terms of some of the tools that we can apply, V8 comes with a built-in profiler, and Node has been modified so that you can actually turn that on using a command line option. So if you turn on the V8 profiler, and I'll show you those command lines a little bit later on, you can turn it on with command line options, or even you can use some tools like AppMetrics as a module you can install, and it will actually let you visualize profiling information. You can also use information about the V8 optimizer. How V8 optimizes your code is going to make a significant effect on performance, and so what the optimizer does can actually, can make a big difference. And there's two options, trace opt and trace deopt, which are often interesting to turn on. So you can see between your good and bad case, was there a change in the optimization profile and the information of what it's telling you what it's doing? Because if there is, that might be contributing to the change that you can see. And then finally, we can also drop down into native profilers, things like perf, tprof, oprofile. There's various ones for different platforms. And they'll give you information about where your application is spending time, not only in the C code, because several of them have been extended to also understand Node.js as well. So for example, perf knows about Node.js, can actually tell you what's going, where time is being spent in your Node.js JavaScript code as well. So that's just a little bit of an introduction to benchmarking. At the end, I'll flip back to an example where we apply some of those tools and techniques. But now I'm going to tell you about what's going on in the benchmarking workgroup itself. So the key goals of the benchmarking workgroup are to avoid regressions, and basically we want Node to be faster every release, not slower. But we also want to be able to track and evangelize when we get faster, which is a good thing. How are we planning to do this? Well, we want to define a set of use cases. We then want to identify a set of benchmarks that cover those use cases. And then we want to run them regularly and publish the results so that people know the effect of changes that are being made. And if there are regressions or gains, we can act appropriately when those things happen. If you're interested in delving in more in the details of what we're doing, you can go to the GitHub, nodejs.benchmarking, and catch up on all the issues and stuff like that. So what have we done so far, and what have we accomplished? So far, we've gone through and we've defined the use cases. So you can see we've defined these main use cases for Node.js, and they include things like backend API services, service-oriented architectures, microservices, single-page applications, even agents and data collectors, because Node fits nicely as a small footprint agent, small scripts. And so the goal is that we want to cover all of these in our benchmarking. If you see use cases that you think are really important for Node that aren't here, just open an issue on the repo, and we're always looking to make sure that we've covered all of the use cases appropriately. As we discussed the use cases, the other thing that became apparent is that in addition to looking at use cases, we also want to look at key attributes for Node. There's some things about the Node runtime that people just felt were really important. And even outside of a specific use case, we felt it was important to maintain that. So it's sort of like the micro benchmark versus the whole system type thing. So things like the startup time, the footprint, the amount of memory that you use, even the size of the binaries, both zipped and unzipped. All these are key attributes and things that we want to make sure that we don't regress in terms of Node.js. So those are things we'll consider benchmarking in addition to the use cases as well. So we took those use cases, we took those attributes, and we built our table that says, okay, here's our use cases and our key attributes, and now we want to fill this in with benchmarks. And so we've started the work of going through identifying benchmarks. Acme Air was one of the benchmarks that was already out there in terms of a whole system benchmark, so it's one that we've actually implemented as a first one. Some other people in the community contributed benchmarks for things like require. Requiring modules is a key thing when you're running small scripts, so we want to be able to do that quickly. Startup and stop time, there was a benchmark already as part of the core benchmark, so we reused that. And basically, we took those and we started filling in this table so that we have some partial coverage in terms of those key elements and what we're benchmarking. Building on that step, we then say, well, okay, we wanted those benchmarks that we have identified, we want to run them on a regular basis and capture the results. So we actually, if you go to the community CI, you can see in Jenkins that we have a number of jobs, and we run and capture those benchmarks across 7, 6, 4, and 12 right now. And you can see that, you can go and see that they're running. You can actually inspect the results from the particular run. But in addition to that, we also want people to be able to easily consume that and see how we're doing. So if you go to benchmarking.nodejs.org, we take that data and we chart it every night, so there's an update. And this shows the performance for Acme Air, for the required benchmark, nightly for each of those different releases. So you can actually say, okay, how are we doing? And it was used in the, when 6 came out to show that, Acme Air, the transaction and throughput increased because we'd pulled in a new version of V8 and other changes had gone into Node.js. So this gives us a watchdog in terms of what's going on that you can visually check out. And again, our aim is to build this up, add things like notifications so you can automatically be notified when things go wrong. So that's how far we've gotten so far. The things we're currently working on include expanding those benchmarks. So as you can see, we have our use cases, we have our key attributes, and we have some benchmarks, but there's a lot of space in that table. We need help filling in that table, and that's what we're working on. And if you have time or energy, it's a great thing to get involved in as well. The other thing we want to work on is that Node.js Core includes a good set of micro benchmarks, but they are often somewhat difficult to run consistently on your own machine and can actually take a long time. I think some of them run in the default mode take like 6 hours to run. So we're looking at setting up some CI jobs so that people can more easily run those from the CI when, if you want to check out your commits and stuff like that. So that's the other thing, a sort of stream of activity that's going on right now. So that's what's going on in the benchmarking workgroup itself. Now I'm going to flip back to an example of a problem that we ran into and the story of how we went through investigating it. This was actually done by Gareth Ellis, who was a member of the team that I work in and does the performance evaluations that we run internally on Node for every release that we do. We had this micro benchmark, and it was basically just checking the performance of the buffer, the new buffer. So basically, it would say, okay, let's create a buffer with those, an array that has those values, and we're just going to do it a whole bunch of times as fast as we can. The performance between 4.4 and 4.3.2, we could see that there was about a 40% regression. So it's like, well, wait a second, something's obviously not going in the right direction here. We're slowing down by a significant amount. So some of the tools I introduced in the first part, let's take a look at how those helped us figure out what was going on. So the first thing was we turned on --prof, which is the option that lets us capture V8 profiling information when we're writing our Node application. That's going to generate us a file. We then need to post-process that file so we can actually look at it and understand, get it into a readable format. In Node, I forget which version, I think it was sort of a 4.6 version, we added the option to add --prof process, which lets you take the file that was generated and convert it into the readable format, and you can end up with a file that you can then read. There are other modules like V8 Profiler that can help you gather and visualize this information as well. Having processed it with the tick processor, this was the difference between the good and the bad version. And you can see we're spending a lot of extra time in lazy compile in the from object option. So this immediately says, it looks like something going on in this from object might be involved in what changed. We also said, okay, that was using the built-in V8 profiler. Let's take a look at the native profiler. So we turned on perf. And here's the example of the command line we used. The magic, this --perf basic prof is what tells perf to use its knowledge about Node.js. It says, okay, we're profiling something that's Node, so it actually knows how to map some of the JITted code back into the JavaScript that was the source, and so you can get information about what's actually going on in the JavaScript level. And if we diff those, it basically also told us, well, wait a sec, we're spending a lot more time in the lazy compile for that from object method. The other thing we thought we'd look at is, okay, this is looking like maybe something related to compilation, so let's turn on the trace op and trace deop and see what that's telling us. Is there something different going on in terms of how V8 is optimizing the code? And we can see in this case is that in the bad case, we saw the message that says the method's being de-optimized. And it's like, okay, well, that's not a good thing. Instead of running the optimized code, V8 is deciding that for some reason I now have to de-optimize that method. And that would explain why we saw more code in the lazy optimize. At that point, it's like, okay, we're pretty sure we know roughly where it is. And we can go, in this case, we didn't need to do it so much because we had a pretty narrow pointer to where to look. But in the worst case, you can always fall back to binary chop, where you basically compare between the good and bad. Git revlist is a tool that lets you basically say, well, here's the list of changes between two versions. That can be pretty helpful. If you want to look at every one of those, it could be pretty time-consuming. So git bisect is another option that basically says, if you tell me a good and a bad, it'll suggest you another hash to try, and then you tell it whether that was good or bad, and it helps you sort of narrow down your bisection to figure out where you want to look. When we finally narrowed it down, we could see that the change was actually a change from var to let, and it turns out that in V8, the implementation for lets, particularly in loops, is not fully optimized yet. So they're working towards turbofan, which is a newer version of their optimizer. Once that's on by default, let's performance will be much better, but until that point, let was actually much slower than using var in this particular situation. So PR was submitted, and we reverted back to the original code in this case. So that's an example of how we applied those tools, investigated an issue, and did that in the benchmarking work group, contributed to change, and restored the performance. So I think I'm almost out of time. My last thing, I just want to say is, as you can see, we had a good-sized matrix. We have a lot of gaps. There's a lot of work, a lot of other things we could do in terms of benchmarking, making it easier and faster to identify changes. So if you have time or interest, please come on out. We're always looking for more people to get involved. Thank you very much.
We have some time for questions. Does anybody have any questions?
Sure.
So with the graphs on the benchmarking site, there was like several that were just way up there or way down. Is that just like you find a regression and then you go fix that?
You mean the individual points?
Right. So it seems like kind of a consistent pattern of the timeline. Is that coincidental as well?
There's two things. So some of those are, I don't know if those are just an outlier.
Yeah.
So I don't think it was a regression that got fixed, because generally those will go up, they don't get fixed that fast. It's plotted every night. The other thing to look at is actually those scales are compressed, so they're not necessarily absolute starting at 0. So the variation may not be as big as it looks in those charts. And there were some issues. We had a discussion. It's like, should we start from 0 so those things are a little blip? Or should we start relative so you get more data? And I think that contributes a bit to that as well. So that may only be like a 1 meg footprint difference, but because we're only 10 meg, it looks like 10%.
Okay, cool.
Other questions?
Hello? There's been a kind of a wave of, do I have to talk that close to it? Of ES6ization across the Node code base. Like there's tons and tons of PRs changing vars to lets just like everywhere. Is that perhaps not a good idea?
Those are mostly in tests. So I think that was discussed, and I think most of the places you'll see those PRs for, it's in tests where we're not as worried, right? Like obviously not in the benchmark tests, but in just the plain functional tests, it's not going to have an effect. In terms of let, for sure, there's, we've got very specific cases where, don't do it at all. And there was a big discussion about these changes from lets to vars, and I think the answer was we directed the community to say, well, let's go do it in the test because we're not concerned about it there. We'll figure out the story longer term whether we want to do that in the rest of the runtime itself.
Okay, but we should be keeping a sharper eye out on our actual code,
Yeah, and the actual code itself, I certainly on the lets, if it's in a loop, for now, it's like, don't do that.
So when there's a Semver major release, I'm looking at the graphs, it seems like there's kind of been a jump up or down, depending on up or down which one. Is that kind of standard for it to get a little better, worse, whatever the right one is?
Often some of our releases include a new version of V8. The V8 team works hard to make things get better in each release. So when we pull in a new V8, it's quite common that we're going to see a bit of a bump. It's actually good that we see, Acme Air going up, which was our whole system that, okay, real life performance is hopefully getting better. And if some of the other ones, there are cases where some of the other ones went a little bit down. So for example, we've just added Octane. And actually, Octane, it doesn't actually show up on the front page yet because we haven't got but that one you can actually see in some versions it's gone down, but it's more of a micro benchmark. So I see that's a good example where, the micro benchmarks aren't the full story. They may go down, but you get better overall performance. And even the V8 team would, has been involved in this and said, well, no, that doesn't matter. The overall performance does matter. So, but it's not unexpected that we see that at the December majors.
Excellent. And we are out of time. If you have more questions, please find Michael afterwards. And it's now a break. Give Michael another round of applause. Thank you.
Thank you very much.